Unit 7.2 ArrayList methods. So we're going to walk through 11 of them. What I'm going to do is I'm going to make a list and show how each one of these methods actually run and perform whatever task they're trying to perform. So the first one is size, and that returns the number of objects in the list. The is empty is a boolean, returns true if it's empty, false otherwise. Add an object at the end of the list. Add an object at a specified index. Contains is another method that says if this thing contains this object or not. Get gets you the object at a particular index. Set places the object at a particular index. Return the guy who was there before. So this is a kind of an erasing kind of thing. And once you send back the one who was there before, you could also hold on to it, like save it somewhere if you feel to do that. And then remove an object. That's if the object is there. The first occurrence is gone. Remove the object at a specified index. It's going to take it out if that index is valid. And then turn the list into an array, and clear removes everything. So what I'm going to do then is I'm going to go through each one of these just to see how they work. So what I have here is an array pre-populated and created of candy names. So we have Reese's peanut butter, Snickers, M&Ms, and so on. Then I have an empty list. You got to remember that this list is a list of strings, so it's parameterized. And this list is called candy list. The array is called candy array. So I'm going to be working with these two to just see how these methods work. So the first method we come across is size. And size, right here, I have the candy list size and I have the array length. Remember, one of the differences between an array and the list is that the array uses length, no parentheses here, and this one uses size. It's a method. So I'm going to run that to see. Run it. And here we have 10 and 0. That makes sense because this has 10 candies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is empty, so it should be 0. Next method on the list is empty. So I'm going to just keep going down and doing each one. So is empty. Is empty. Let's see. Is the list empty? Should return true. So let's run that and see. It does return true. It's empty. Nothing has been added yet. Well, clearly since it's empty, we need to add things. So I'm going to go ahead and add some stuff to this list. I'm going to do adding the values from the array into the list. And I'm going backwards. Since there are 10 things, remember, off by 1, Mike's and Ike's would be at position 9, 8, 7, 6, 5. And that's exactly what I added. So what's going to happen? The candy list at position 0 would have Mike's and Ike's. The guy who is at 9 is going to be the first guy in the list, which is going to be at position 0. And then the guy at 8, Jolly Rancher, will be at position 1, and so on. I also print the list every time I do any of these methods to see how the list updates. So I'm going to run that, and exactly as we expected. Mike's and Ike's, okay, that's first. That's at position 0. Jolly Rancher at position 1, Tootsie Pops at position 2, Starburst at 3, and Skittles at 4. 5 things are in the list. Clearly, if I ask what the size is right now, it would print 5. Actually, let me go ahead and do that. So let me go ahead and just print out what's the size of the list right now. Let's just take a look at that. Dot size. I'm going to run it again. It should say there are 5 things in the list, exactly as we expected. The next thing I'm going to do is I'm going to start adding at specific spots. See, this first adds at the end. So everything got added right in the order, but now I could add things at specific spots. So for example, take the guy at position 0 in the candy array, which is the Reese's peanut butter, and put him at position 2. So how would that work? Well, let's go ahead and check that out. I want to check them out one at a time. So let me do that and see. So let's see. Remember, the guy was Reese's peanut butter at position 0, right? Let's go ahead and find the code at position 0. And he went to position 2. So that means then this guy at position 0, Reese's peanut butter, should go to position 2, 0, 1, 2, where the Tootsie Pop is. Now, it doesn't replace the Tootsie Pop. No, what it does, it puts the Reese's peanut butter here and pushes everything to the right over 1. So Tootsie Pop's going to bump over, Starburst and Skittles are going to all bump over. To see that, I'm going to go ahead and print it. So every time I make a change, I print because I want to see how the list looks. See, this is the new list now. Mike's an Ike's Jolly Rancher. See, Reese's peanut butter that used to be from the guy from 0 gone to position 2. Everybody got pushed over 1. So you could see how everything is pushing over and pushing over when we add at a specific spot. Now that spot has to exist. So make sure that spot exists first and then we could do that. So let's go ahead and just add some more. So I'm going to add the guy who is at position 1 in the array at position 3. So let's see how that looks out. Okay, so position 1 is the Snickers, and he's supposed to be at position 3. 0, 1, 2, 3. Snickers at 3. Everybody got pushed over. Okay, so I'm going to go ahead now and just run a bunch so we could see how they all work. So here we have the guy at position 2 in the array going at 4, and then the guy at position 3 is going at 5. I'm going to run that and check that out. So here's how the list looks finally. Okay, everything is now in the list because we've added everything from the candy array to the list. So we have all of it now. Now clearly the size of the list should be 10 now because we've added everything. So let's go and check that. Let's go and check that. We got 9. So that means we didn't add something. So let's see which one we did not add. We had 0, 1, 2, 3, where we didn't add number 4 from the list. So we have 0, 1, 2, 3, but not 4. Let's go ahead and add the guy 4. Let's go ahead and add 4. So I'm going to add him right here. Candy list dot add. So we're going to add at position 0. I'm going to put it. I'm going to put this candy array 4. That one was missing. So let's run that and see what we get. So now we should get the size being 10. All right, so we have 10. So everybody's in the list now. Okay, so we've added everything. And again, let me run that so we could see the guy at position. See, candy corn now is at 0 because I added the guy in 4 at position 0. So let's look to make sure 0, 1, 2, 3, 4 candy corn goes at 0. That just makes sense. So we've done all the adds. Now we got to do a contains. Now contains is a method that just says whether it contains this or not. It doesn't really do anything with the list per se. It just determines if it contains it or not. So I'm going to go ahead and print this list and ask it if it contains a particular thing. The thing that I'm going to ask you if you contain, do you contain Starburst? It should say true. Okay. And then the other one I want to do then is I want to ask if it contains something else. Okay. What about if it, do you contain gum? So it should say true and false. So let's run that. Yep, it contains the Starburst but no gum. Okay, now we keep going down. We have a few more methods to go. We got to do the get, the set. All right, these getters and setters are all over. Have to do the get and the set and then the removes. So let's go ahead and check those out. First one is the get. So for get, I am asking to get me the guy at position 6. Store it as candy. I'm going to print the list and print candy. So let's go ahead and check that out. Very last 2 lines. The guy at position 6 that says Hershey bars. Let's check that. 0, 1, 2, 3, 4, 5, 6. Yeah, Hershey bars is at 6. Perfect. So that's how getting works. You just have to have a valid index here and it's going to get you the thing. Now one thing I have to do is I have to show you when we get something, it doesn't remove it. Okay, it just tells you what's there. Okay, it's still in the list. Some people get that confused. All right, set. Now set would actually remove something. So if I set worth as original at position 6, let's run that and look at the list again, last two. Look at what happens here. Let's look at position 6. So we have 1, 0, 1, 2, 3, 4, 5, 6. See, worth as original goes at position 6, right? But let's see. When I set, so let me go ahead and look for that. When I did set this guy to position 6, this does two things. It not only sets it there, but it returns the one that was there before. So I set this guy, the worth as original. Let's find that back in view. I set this, oops, running away. I set the worth as original on top of the Hershey bars, because that was in 6 before. And so what happens then is I save the Hershey bars because it returns it, and I save it as candy. That's why I printed Hershey bars here. All right, so I'm going to keep going down. Now we're going to do, so this set does two things then. It puts something in a spot and removes the stuff that was there before and send it back. All right, now we're going to work with remove, specifically removing an object. So if I try to remove Starburst from the list, Starburst will not be in the list after this thing's finished. So let's look at the list before. The list before had Starburst here, right before the Skittles. Well, if you look in the list on the bottom, no Starburst, see? Tootsie Pops, then Skittles. Tootsie Pops right here, then Skittles, no Starburst, it's gone. Now, I could save something that I want to remove before by using a set, but if I remove this, it's not going to send back what was there before. It's just going to send back true or false, whether it was removed or not. Index. Remove at a particular index. Same idea, except instead of telling you specifically what to remove, I'm telling you where to remove it from. So if I'm removing the guy at 0, let's see what happens. Candy corn is gone. See, candy corn was at 0 before, then Mike's and Ike's and Jolly Rancher. But now, look at what happens with remove. When you remove something at a specific spot, the list shifts over to the left one. See, candy corn goes away, and that makes Mike's and Ike's, who used to be at position 1, now is in position 0. This is very critical because since the list grows and shrinks like this, moving things around, if you're writing an algorithm on it, you have to be careful because every time you call one of these things, the list is going to change. Adding at a specific spot, push things over to the right. Taking something out, shift things to the left. So we got to be really careful when we're writing these algorithms here. All right, so now we move on to array. I'm just going to show you these last two because these are good methods to have and to know. Some of these methods are not necessarily on your AP exam, but I think this is a good comprehensive list. It's not all, it's a good comprehensive list of the stuff that are frequently used. So here we have to array. It turns this into an array and save it as candies. And then I'm going to print the list and print, so it doesn't change the list, it just makes an array for you. So we could see that the list is still the same. Mike's and Ike's is the guy at position 0. How do I know that? After I created the array, okay, turned the list into an array, I printed the guy at 0 in the array, not the array list. I also printed the list to show that the guy who's 0 in the list is also the guy who's 0 in the array. See, Mike's and Ike's is 0 in the list, Mike's and Ike's is 0 in the array. Now, this method here, it sends back an array of objects, so any objects, because it doesn't really know what's inside the list when you call this up to array. There's a different to array with parameterized, but since I'm only showing this one, if you wanted to put this into an array of strings, let's say you say, you know what, these are strings in here, it's going to throw an error. It's going to say, hey, this is not right. You can't convert from object to thing, so we got to cast. Bringing back an old topic. I'm going to cast. Now, clearly, if it's not correct, if you can't create this, it's going to throw an error. So let's just run it and see. Perfectly fine. Well, shows an error. See? Now it says cannot be cast to a string, right? So let's go back and check to see where my error is. So we're trying to turn this guy into a string array. It looked like it's good, but it's saying, hey, we can't do that. So that's the only drawback with this, is that we have to do a number of things with this type of setup here to use them. Now, one thing here though is that even though it's an array of objects, we could go ahead and write our code to make sure it's a string and then use it if you need to do this. So this is a way to go from a list to an array. If you find that necessary, you can use the to array. It's something that's not frequently used because we usually just work with the list, but sometimes you may need it. So it's very seldomly used, but good to see. And then finally we have clear. Clear is a method that simply does what it does. It clears out the list. So if I run this, there will be nothing in the list. When I printed one empty, we started empty, we end empty. Clear is not a method that you will normally call unless you do necessarily want to get rid of everything that you already have saved somewhere or something like that. But these two are not frequently used, but they're good to see that they do exist. The others are frequently used though, so from here on up, from this remove all the way up. These are the array list methods. These are what we're going to use to write algorithms when working with array lists. That brings us to the end of 7.2.